this question here. And notice that this is a calculator question. So when you see this, you'll have, when you take the AP exam, you're going to have access to Desmos right on your computer, or you can use your graphing calculator. I want to show you how to solve this two ways, because I see you are doing it algebraically. And so I'll make a second video on how to do part A algebraically, but I also want to show you how you can make this really fast on your calculator because you're allowed to use it. So if we go into Desmos, we want to go up here to this little plus. We want to add a table. And we're in the question they're using t, but we know that the inputs are x values. So we have 0, 35, and 45. And then we have 14, 57, and 46. And if we go back and look at the, we can change this so we can see these values here real quick. So the little wrench up here changes it. So we can see x goes all the way up to 45. So let's make x go past that a little bit to 50. And then y, let's say -10, it goes up to 46. So we can also say 50. And then we can see these points. Oh, we need a little bit higher on y. I didn't quite go up to high enough. Sorry, we need to go to 60. And we can see the points here, and we can see definitely that this looks like something like a parabola. And it's even telling us that it's modeled by a parabola or a quadratic function. So in Desmos, we can get the values, to find these values, the coefficients of a, b, and c. We can go here, and this will do this very fast for us. If we put y sub 1, because we're telling the computer that we want to use these y values, and there's a little, if you look up by your 1 key, there's this little squiggly, and that is Desmos's way of saying let's run a regression. And what do we want it to do? We want a x1, because we want the values coming from here, and we want to square that. And then we're going to say plus b x sub 1, and then plus c. And you'll notice these values of a, b, and c are given to us right away, and that makes this problem, right? Once you have the values, and you see you found those values, you did the same thing. And I'm going to solve this secondly algebraically and then finish the problem, because the rest of it you do need to write out. But just so you know, if you have a calculator problem and you're given a data set, then, and especially when you're told what kind of model it is, then you can easily go. If I didn't know what kind of model it was, I could play around to see what goes through the data best. This r squared, when r squared is 1, it's perfect. The data fits perfectly through it. If I was trying to see, like, we're doing exponential right now, right? So if I wanted to say, is y1 like a, b raised to the x1? And I wanted to see what happens. Oh, it tries to run the data through, but r squared is not closer to 1, right? So the closer it is to 1, or if I wanted to see, does it fit a linear equation, right? You need to put a 1 there, and no, right? We don't have that r squared saying, r squared is a way of saying how well the variance of the data fits. So we can clearly see this is a quadratic, and if you weren't given it was a quadratic, I think even if you just saw the points on the graph, you would say so. So that's the fastest way to solve this, and then I'm going to finish the problem on my iPad and send a second video.